Happy Thursday. Today's target is to be able to convert the grams of one substance into the moles of a different substance. Before we really get into today's target, I want to take a little bit of time and flesh out an idea that I did talk about in Wednesday's video, but I just want to expand on that a little bit more in this video. That distinction that I want to talk about, it's the difference between a mole ratio and molar mass. What are these things? How are they different? Okay, so here's the equation that we had yesterday, or the recipe we had yesterday. We had 6 eggs, a cup of cheese will make 2 omelets. And from that, we made a bunch of different conversion factors, and I kept them on a long list on our whiteboard. But let's talk about what these things mean. First of all, we see this term mole kind of popping up. So what is a mole? A mole is simply an amount of a substance, okay? Just like a dozen. You can have a dozen eggs or a dozen loaves of bread. You have 12 of each, but they're very different. 12 eggs and a dozen loaves of bread, different sizes, different shapes, different masses. They're extremely different. They just have the same number. That's kind of what a mole is. A mole is just Avogadro's number of particles. For example, you can have 1 mole of water. And I recognize it's a little difficult to see. I can move it closer to the camera. But like 1 mole of water is really only about 18 milliliters of water. And you can have a mole of sugar, which is like 350 grams. It's significantly more massive than 1 mole of water. This is because sugar molecules are bigger. And so while we have the same number of molecules in both of these containers, because the sugar molecules are bigger, it has more mass. It takes up more space as well. Okay. All right. So a mole is just an amount of a substance. So what is the difference between a mole ratio and molar mass? Okay, let's talk about mole ratios first. Mole ratios, it's just comparing the moles of 2 different substances, right? We established that 12 eggs are going to be significantly smaller than 12 loaves of bread. However, there is a ratio between eggs and loaves of bread. Eventually, I don't know how many eggs it would be, but eventually X number of eggs would have the same mass as X number of bread. That's a mole ratio, right? We're just comparing the amounts of 2 different substances until they're equal. 1 mole of egg is not the same as a mole of cheese, right? They have different masses. However, 6 moles of egg is equal or is equivalent to 1 mole of cheese. And we know that because of the ratios, because of the coefficients in our balanced chemical equation. That's where these mole ratios come from. They come from the balanced chemical equation, and they're just helping us figure out what's the relationship between 2 different substances. Okay. All right, molar mass. So molar mass is a concept we've actually been using all year. It's simply the mass of a mole, right? So if I have 100 grams of egg, and that happens to be 1 egg, then 100 grams of egg equals 1 mole of egg. Or if we were to write that in the notation that we have been this year, egg's molar mass is just 100 grams per 1 mole. These 2 statements are exactly the same thing. They mean exactly the same thing. And using the molar mass and using mole ratios is going to be very important to hitting today's target. So let's get into that now. Let's talk about how we're going to hit today's target using s'mores. Here we go. Okay, so let's just take a quick minute. Go ahead, take a moment and jot down this equation, and I'll explain what it is once you've got it written down. And create a copy of this data table in your notes as well. You're going to want both of them in order to do what we're about to do. So pause the video and get those written down in your notes, and then we'll talk about it. Okay, so now that you've had an opportunity to write this equation and this table, let's talk about what they mean. So this is just the recipe for how to write a s'more. You take 2 graham crackers, you take 1 marshmallow, and you take 3 chocolate pieces. This is 1 chocolate piece. Okay, so, and then you combine all of those things together to create a marshmallow sandwich, which is called a s'more. You can Google one if you've never seen a s'more before. They're also delicious. I encourage you to consider making one. Okay, so what we did was we went to the grocery store and we got ourselves a box of graham crackers. Here, let me grab it. There we go. Okay, so we got ourselves a box of graham crackers. We got ourselves a bag that was at one point in time full of marshmallows. And we also got ourselves a package of chocolate. Okay. I've also got this handy dandy electronic balance. And so what we're gonna do is we're just gonna measure how much graham cracker, marshmallow, and chocolate we have. Okay, the reason that we're going to measure these 3 things is because we are trying to figure out how many s'mores can I actually create if I have a box of graham crackers, a bag of marshmallows, and a container of chocolate. And the rules are with this, we want to try and do it without actually opening them. We want to try and keep them fresh and intact. Let's say we're having a party later in the week, and we want to see if we have enough graham crackers, chocolate bars, and s'mores, or marshmallows to make the number of s'mores we need, okay? So yeah, we can't just like count them out. That would be cheating. So first things first, let's measure them. Let's take out our handy dandy balance, and I've actually already gotten this data. I've put my different substances onto that balance. So let me just jot this down for you. The box of graham crackers had a mass of 457 grams. The bag of marshmallows had a mass of 340 grams. And the chocolate bar package had a mass of 282 grams. Okay. So there's that. We also, we took the masses of just 1 graham cracker and just 1 marshmallow and 1 chocolate bar. We put those on our balance and we got those as well. The graham cracker had a molar mass of 16 grams per graham cracker. So like 1 graham cracker had a mass of 16 grams. And 1 graham cracker is just the same as 1 mole. So the molar mass of a graham cracker is just 17 grams per mole. Let me show you what I mean by that. So like what I did was I took my balance and I put a graham cracker on it. And this is gonna say, it's hard to see based on the lighting and things like that, but it's going to read 17 grams per 1 graham cracker. That's what our molar mass means, okay? The chocolate bar, I think that was 5. Let me double check. The chocolate bar, yeah, the chocolate bar was 5 grams per mole, and the marshmallow was 7 grams per mole. Cool. Okay, we also need to know the mole ratio between these substances and a s'more. So graham crackers have a mole ratio of 2 to 1. It takes 2 graham crackers to make 1 s'more. What are our other 2 mole ratios? So the second one is 1 marshmallow per 1 s'more. Each s'more that we make is going to require 1 marshmallow. Okay. It's going to take 3 chocolate pieces to make 1 s'more. 3 chocolate pieces to make 1 s'more. Cool. Okay, So now we get into the mathematical part of what we're doing. Now we're really going to start to get into the stoichiometry, the calculations of what we're doing. So in all of these problems, there's always a number that we are given. That we have a certain amount of a substance, either in grams or in moles. And we'll have to convert that into moles or moles of a different substance. Okay? Let me show you what I mean. Let's use graham crackers as an example. So we're going to start off with our starting amount. Makes sense, right? So we've got 457 grams of graham cracker. Notice how I wrote this number. It has a number, it has a unit, and it also has a type of substance. From here on out, for every single problem we do today, anytime that you're writing a number down below this data table, it needs to have a unit as well as a type of substance, and you'll see why in just a second. But make sure you're not taking any shortcuts. You want grams of graham cracker. Okay. All right. Now we need to use one of our conversion factors. We know that a graham cracker has 17 grams of graham cracker in 1 mole of graham cracker. So we're going to put 17 grams of graham cracker on the bottom, and we're going to put 1 mole of graham cracker on the top. And what this is going to do is it's going to convert our units from grams of graham cracker into moles of graham cracker. Okay. So when I do that, I'm going to figure out that I've got 26.9 moles of graham cracker. Great. Now that we've got 20, here I'm actually going to rewrite that just slightly. No, that's fine, that's fine. Now that I've got 26.9 moles of graham crackers, the next thing that I need to do is I need to convert this into the number of s'mores, right? Into my moles of s'more. Because that's what we're trying to figure out. We're trying to figure out how many s'mores can I make with this much graham cracker? How many s'mores can I make if I've got 340 grams of marshmallow? How many s'mores can I make if I have that much chocolate? We're trying to see if we've got enough of these materials to make the s'mores that we want. Okay. All right. So we've got 26.9 moles of graham cracker. That's going to be the number that we start with, 26.9 moles of graham cracker. And what we're going to do is we're going to use our mole ratio to get moles of graham cracker into moles of s'more. Let me show you how. So we're going to put moles of graham cracker on the bottom. And since it's 2 moles of graham cracker, we're going to put 2 moles of graham cracker. And since it's 1 mole of s'more, we're going to put in 1 mole of s'more. The reason that I put the 2 moles of graham cracker on the bottom is because I need my moles of graham cracker to cancel out. Cool. When I do that, I take 26.9, I divide it by 2, and you end up getting 13.45. You can't have half of a s'more, and so we'll just round it down, and we would create 13 s'mores. Assuming we've got 457 grams of graham cracker, which we do. All right, marshmallows time. Let's talk about the marshmallows. Okay. All right, so in all of these problems, there's a number that we start with. And with this one, it's really nice because our starting number is just the starting amount. We've got 340 grams of marshmallow. Now what? What am I going to do? How am I going to find the moles of marshmallow? What am I going to use? I'm going to use my molar mass. I know that the molar mass of marshmallows is 7 grams per mole. So I'm going to put 7 grams of marshmallow on the bottom so that my grams of marshmallow will cancel out, and my 1 mole of marshmallow is going to go on top. Okay, grams of marshmallow cancel out, and when we do that, there it is. We get 48.6 moles of marshmallow. Okay, so 48.6 amounts of marshmallow. Or another way to think about it, we've got 48.6 actual marshmallows. Cool. So if we've got 48.6 actual marshmallows, how many s'mores can we make with that? Well, let's start off with the number that we've got, 48.6 marshmallows. And how are we going to get that into moles of s'more? How are we going to convert moles, numbers of marshmallows, into moles or numbers of s'mores? We use our mole ratio, right? 1 marshmallow makes 1 s'more. So 1 mole of marshmallow is the same as 1 mole of s'mores. Our moles of marshmallow, they cancel out, and we've got 48.6 moles of s'mores. So we've got enough marshmallows basically to make 48.6 s'mores, although we'll have to round it down, right? Because you can't have 0.6 s'mores. So we've got 48 s'mores. All right, let's do the last one. See if you can solve this last problem without my assistance. Start to finish, see if you can figure out if we've got 282 grams of chocolate, how many s'mores can we make with that? Do both parts just like we did in the previous problem, and then we'll go over it to see if you're right. Good luck. Now that you've had an opportunity to go over it, let's see if you're right. So we take our given 282 grams of chocolate pieces, and we're going to multiply that, or rather divide it really, by the molar mass. So that's going to be 5 grams of chocolate piece divided by 1 mole of chocolate piece. When you guys were putting your numbers into your work, did you put the unit? Did you put the substance? Anytime that you write a number in these types of calculations, it's really important to include both. And here's why. Okay, we do our calculations. 282 divided by 5 grams is 56.4. Nice. Okay, 56.4 moles of chocolate. Which basically means we've got 56.4 chocolate bars in our container of chocolate. Okay. So why is it so important to include both the unit and type of substance? Well, if I don't include the unit, I won't know which number to put on the top or the bottom. If I just had 5 and 1, it would be very easy to put 5 on top and 1 on the bottom, right? When I include those units, I don't make that mistake. And when I'm doing my mole ratio step, because I've written in chocolate pieces right here, I know that moles of chocolate pieces has to go on the bottom because these are the same unit. But if I didn't have chocolate pieces right here, if I didn't include that, I could make mistakes. Okay. And frankly, people do make mistakes. No, it doesn't matter how good you are. Like if you don't show, I make mistakes when I don't show my work. Actually, like a lot. It's really shocking how many mistakes I make when I don't show my work. And you guys are no exception, right? You can try and take shortcuts, but sometimes those shortcuts are going to burn you. So show your work. Okay. So it's 3 moles of chocolate pieces to 1 mole of s'mores. 56.4 moles of chocolate pieces. The moles of chocolate pieces cancel out. 56.4 times 1 divided by 3 is 18.8, which would round down to 18 s'mores. We have enough chocolate pieces to make 18 s'mores. Okay, so now that we're getting close to the end of this problem, we actually need to figure out how many s'mores can we make. We've got enough graham crackers to make 13. We've got enough marshmallows to make 48. And we've got enough chocolate pieces to make 18 s'mores. But how many s'mores can we actually make in this problem? Well, what happens once we've made 13 s'mores? Is there any more graham cracker left? No, there isn't. The graham cracker's all gone. We've run out of graham cracker. So even though we have enough marshmallows and enough chocolate pieces to make 48 and 18 s'mores, once we get to s'more number 14, we don't have any more graham cracker to make it. So we can't. We can only make 13 s'mores. So, if we were to throw a party a week from now, we would have enough ingredients to make 13 s'mores. And if that party needed more than 13 s'mores, we would need to go and buy more graham crackers. There you go. This was a much more complicated stoichiometry problem than we have done in days past. Stoichiometry is a huge branch of chemistry, and we've kind of gotten a bit of a taste of stoic. But stoic really is one of the fundamental pillars of science. If you do take chemistry in college, this is going to be a really big piece, a very valuable piece that you're going to learn again in your first year, and you'll use every single year after that. In fact, I've taken some physics courses, and we've used stoichiometry in those physics courses. I have not taken any biology courses in college, but my wife has, and she also used stoichiometry in biology. Likewise, stoichiometry has a ton of application to the world of cooking, to the world of actually finances as well, and incredible numbers of magnitude and application when you really start to get into the quantum world or the numbers world. Okay. Friday is a work day. Finish up your guys' projects, post those pictures onto the assignment page. I'm so excited to see all of the things that you guys have made, and we'll come back together on Monday. Additionally, this afternoon, Thursday afternoon and Friday afternoon, there's a social hangout. We'll do some just kind of catching up with each other. We'll play some games. So please feel free to join us. We'd love to have you. Anytime between 1 o'clock and 2 o'clock. Cool. Bye, folks. See ya.